Okay, so today we're going to talk a little bit about the section 1.4 homework for module 1. This one's going to be all about writing the equation for lines, and we're going to do it by hand here. In a later lesson, we'll do it with the calculator with a method called linear regression. But for this lesson, we're mostly focused on the calculator methods. So there's going to be a few questions in this homework assignment and potentially on your exams that are pretty simple if you know the basic premises of this. Like this is a good example of that. Remember, a linear equation in standard form, or I'm sorry, in slope intercept form looks like this: y equals mx plus b. And with these equations, the x and y, they're going to stay variable. So really, we just need two things to get our equation for our line, our m and our b. If we can figure those out, we're done. So our m, if you remember, is our slope. And we've talked about how to get that with the slope formula. We can also get it pretty easily from graphs like this. We'll talk about that in just a second. Remember that this b value here is the y value of your y-intercept. That's the point where we cross our y-axis. So if we can get those two things, we're just done. That's all we need. And they're pretty easy to get from a graph like this, as long as we have like clearly defined points like we do on this one. Okay, first off, this y-intercept, you can just read it right off the graph. That's the y-intercept is the point where our graph crosses the y-axis. And so in this case, it's just right up here at 6. So 6 is our b value. We can just fill that right in. Whoops, sorry. B value is a 6 there. Hey, our m is our slope. And we've talked about how we can get the slope using the slope formula. We could certainly do that here if we wanted. We can get a couple of points off the line and put those points into the slope formula and calculate it that way. That would definitely work, but we don't have to do that. What we can do instead is we can use another definition of the slope and what it is graphically. What the slope is it's the rise of the graph. That's what we get when we do this y2 minus y1 thing, is how much the slope is going up and down over the run. The run is how far the graph of the line is going left and right. So if I want to do that, use these 2 points that are given, I can just draw a little triangle over here that connects these 2 points vertically and horizontally. Okay, and then the length of this over here is going to be the rise. Now you'll notice we're going down. That means our rise is going to be negative. That's how I think about it. I always go from left to right when I'm working on this. Okay, sorry, my cat. So the rise, we went down 3. So I would think the rise is -3. And then the run is how far we go from left to right. So we go 1, 2, 3, 4, 5, 6, 7 over. And so our rise is -3. Our run is 7. Put those together and we get that our slope is -3 over 7. So fill that in and we're done. That's all we need to get the equation of a line is the slope, the y-intercept, put those together. So it's pretty easy to get these equations from graphs like this. We just get our y-intercept and then we figure out our rise and our run, put those together to make our slope. Just one last quick thing to note about this line. You'll notice that as we go from left to right, this line is decreasing. Okay, anytime we have a decreasing line, we know our slope has to be negative. So that's something to think about. If this line had been increasing as we went from left to right instead, we would have had a positive slope. So make sure you're thinking about that. Make sure you're using that to get the right signs on your slope. Okay, so sometimes we'll be asked those same questions, but we won't be given a graph. Like this is an example of that. Assume that the growth of the membership of a country club was linear from 1996 to 2000. The membership was 158 in 1996, and the rate of growth was 652 per year. First equation asks us to write an equation as a function of the number of years X after 1996. So if we're doing that, again, I'm still starting from the same spot. I'm still starting from y equals mx plus b. I'm going to use this slope intercept form equation for all of these types of problems. Okay, there are some other methods that we can use. Your book might use this thing called point slope form. I'm not that interested in this one. Personally, I would recommend just doing all of these kinds of problems straight from slope intercept form. Okay, very straightforward for problems like this. Like, again, we just need two things. We need our M and we need our B value. Okay. And it tells us here that 1996 is the first year we're interested in. X is the number of years after 1996. So X is going to be our 0. So the value of this function in 1996 is going to be our y-intercept. So in 1996, our value is 158. So again, we're just kind of given our B value. This will happen fairly often in these kind of problems. So we know our 158 is going to go in right here. Okay. So then we just need to put our slope in for M. And in this particular problem, this won't always happen, but in this particular problem, they give us our rate of growth. Anytime we see that word rate in these kind of problems, then we know we're being given our slope value. Okay. And it's a growth. Growth, that word implies that our slope is going to be positive. So 652 can go right in for M. Fill in the rest of our function, and we're done. So again, we're given everything here in this particular problem. We're given our slope by the word rate of growth, and we're given our y-intercept, the value at our first year, year 0, which is 1996 in this particular problem. Okay, so the second question here asks us to use the function to estimate the membership in 2001. Again, the key thing here is to focus on the definition of what our X is. X is the number of years after 1996. So how many years after 1996 is 2001? Well, it's 5 years. So we're going to plug 5 into this equation for X. And then we're just going to work that out. So put that in your calculator and you've got it. So I get 3418 for this one. So again, the key to problems like this is really focusing on your scale. What does your X value actually mean? In this case, it's 5 because 2001 is 5 years after 1996. Okay, so this next example, we're looking at a table here that gives the number of drinks and the resulting blood alcohol percent for a man of a certain weight to legally be considered driving under the influence. Okay, so first question asks us to find the average rate of change in blood alcohol percent with respect to the number of drinks. Okay, so anytime we see that average rate of change phrase there, that's the slope. So this one, we're not given a table. We're not given a graph, and we're not given the rate of change directly. So we're going to have to calculate it. And so we're going to go back to the slope formula. It tells me in this problem that this is going to be a constant. So I'm just going to pick any 2 of these points. I'll just choose the first 2. It doesn't really matter here. You can choose whichever ones you want. And because it's a constant, we can pick any 2 points, should get the same answer. So we're going to plug in. Again, it doesn't matter which ones which one we pick for point 1, which one we pick for point 2. We just need to be consistent. I want to get positive numbers where I can. So I'm just going to make this point 1. So this is X1 and this is Y1 and this is X2 and Y2 over here. Okay, so plug it in. Y2 is 0.27. Minus Y1 is 0.23 over X2 is 6 minus X1 is 5. You'll notice I did pick 2 points that were right next to each other. Good reason to do that is so that you get this 1 on the bottom. You don't have to deal with the fraction so much. And so there's our slope. Okay, and that's the answer to part A. Part B, though, asks us to use the rate of change at 1 point from the table. Again, it doesn't matter which point we're going to pick here. We're just going to pick 1 to write a linear equation that models this data. Okay, so to do that, we're going to try to fill in y equals mx plus b. I'm going to focus on this. Again, this is one that your book might be using this thing called point slope form. I would not recommend that. I would just use this slope intercept form for everything. No real benefits to using the other method. This is just a really powerful equation that we use for a lot of things. I would just focus on that. So I'm going to plug 0.04 in for m because I already know what my slope is. And so really all I need to do to finish this up is figure out my B and I'm done. How am I going to do that? Well, I'm just going to pick one of my points. Doesn't matter which one. I'll just choose this first one here. There's an X and a Y in this. I'm just going to plug them in for X and Y. So my Y value is 0.23. Plug that in over here. My X is 5. And I'll just work that out. So start here, 5 times 0.04. Put that in your calculator. And then I'll subtract 0.2 from both sides. So I can get the B on one side. And that gives me that B is 0.03 and I'm done. I've got my M, I found that in the first part. I've got my B, I just calculated it. So I just put those into my slope intercept form equation and I'm done. Okay, so hopefully that's enough to get you off to a good start. Again, I would definitely recommend just using the slope intercept form. We already need to know that for many other types of problems. There's another formula you can memorize for that, but in my opinion, it's not easier and there's not really real benefit to it in future applications. So I would just focus on a slope intercept form equation and using that to get these linear functions that we're going to find throughout this lesson. Please let me know if you have any questions and have a nice day.